Hi everyone, this is Cletus Rajkumar and I'm going to be presenting the project Graph Driven Career Pathway Intelligence Platform on behalf of the team, which also includes Deepesh A and Akash S. The name of our internal guide is Dr. Rajashekharan T and the domain of our project is Artificial Intelligence and Machine Learning. Now, to introduce the main premise for our project and the motivation. So right now, digital platforms and AI tools provide abundant career information, but availability does not always guarantee clarity or structured decision making, which is very important for career related decisions. And so the problem as such right now is that information is present everywhere. Especially in the age of AI, information has never been more abundant, but guidance is scarce. The problem is that career guidance itself is fundamentally not an information retrieval problem, it's a complex multi-dimensional mapping problem. And these are some things which our project tries to solve. Career planning as such involves a lot of interdependent factors like interest, academics, courses, etc., which students often struggle to integrate into a clear roadmap. And a lot of existing guidance systems offer generic and isolated advice, lacking support for long-term planning as well as real-world constraints. Some of the issues and challenges have further been highlighted here, such as fragmented data, where career data is spread up across multiple sources, static psychometric assessments, black box recommendations, where suggestions and recommendations from the platform lack visible reasoning and an explainable pathway, execution gaps, which involve no support for deadlines, applications, etc. So this leads us to the core problem which we have identified and which sets the base for our project solution. So right now there is no unified intelligence system which integrates all career data and adapts to each unique individual profile and provides transparent and explainable guidance, and this facilitates the need for a platform which can consolidate the data from multiple sources, personalize recommendations for each student, and generate explainable, understandable end-to-end career pathways. We have now looked into a lot of existing research papers which provide the key technical contribution for the core of our project. Now, to map this to the existing limitations and how our project addresses it using the latest research data. So first off, for static psychometrics, so currently a lot of platforms use only fixed questionnaires which cannot adapt to individual student profiles or evolving interests. They are a fixed hard-coded set of questions which do not evolve or personalize themselves for each student. Our adaptive psychometric engine uses cognitive diagnostic modeling with multi-turn conversational AI, which essentially means that questions they dynamically adapt based on prior responses, generating a confidence score, and they are mapped to two main frameworks, which is RIASEC and Big Five traits. Secondly, fragmented data sources. To address this problem, we use a Neo4j knowledge graph which models colleges, courses, jobs, exams, scholarships, and all other important information as interconnected nodes with type relationships, and we're going to be using multiple heuristic techniques such as multi-up queries, etc., to trace complete and constraint aware career pathways in one unified graph. Furthermore, for black box recommendations, we use a technique known as GraphFrag, which enriches every recommendation with salary data, job task, and progression steps traced through the knowledge graph. So each output for the student will show a very visible reasoning chain which explains the reason behind the decision made. And finally, execution tracking. We also provide a Kanban style progress tracker which breaks pathways into actionable stages. Now finally, moving on to the detailed architecture diagram. So our project and the core technical architecture of our project can be split across 4 modules. Module 1 is the adaptive question generation agent. So what this involves is the student now signs up and logs into the platform. We are going to be collecting some essential student details, personal, academic, and economic details. Further, then we move on to the personalized psychometric test using an AI engine. which is going to dynamically ask and perform a psychometric assessment of the student. Now there is a confidence score involved here. Once the AI engine is confident that it has successfully assessed characteristics of the student, and this is essentially mapped as a confidence score. Once this confidence score passes a given threshold of say 75%, the results are then shown to the user and used in the next further steps. So after the evaluation and the trait mapping, where the results of the test are mapped to two frameworks, namely RIASEC and Big 5, we move on to module 2, which involves the career recommender agent. So here, to start off, we're going to be recommending, the platform is going to be recommending 3 career journeys. A career recommender agent is involved here, which acts as the central database. This contains essential details of the students which are stored here, for instance login details, student details, and onboarding results and recommendations. Then we tap into the Neo4j graph database, which contains root career data such as colleges, courses, jobs, etc. And based on this heuristic mapping we perform, the recommendations are shown to the student in the dashboard. Next we proceed to module 3. Here there are 3 main sections present here: graph-powered course to career planner, colleges, which shows the decision made in a given reasoning chain such as colleges, courses, jobs. There is also researcher chatbot present in these modules, which provides further assistance to the student, coupled with an evolving feedback loop. And finally, module 4 contains the Canboard board application tracker and career goals, deadlines, eligibilities, etc. Now the system requirements and core tech stack of a project includes Next.js, TypeScript, and Tailwind for the front end. The backend is built on Fast API, and for databases we use PostgreSQL for storing user profiles, onboarding data, and tracking state, and we use Neo4j for the core knowledge graph. For the AI and intelligence layer we use LLMs, Gemini, and the models from OpenAI. And D3.js is used in the application for interactive pathway visualizations. And the core infrastructure for authentication and authorization is built on Supabase. And these are the modules again extrapolated here with some descriptions. Now moving on to the actual implementation showcase. So this is the platform. Now we can go ahead and start the career assessment, which will start the whole process. So initially we're going to be entering some basic information, collecting some basic details from the student such as the name, age, his location, city, the languages spoken by the student, some details about his or her academic journey so far. For example, we can choose 12th standard, the education board he was studying in, the name of his college or school, the year of completion, Now next we're going to be asking a series of questions which tries and understands the user's interest and characteristics. For instance, here it's asking us what kind of work fascinates the student the most. So here, for instance, we can choose cracking logical puzzles and patterns. Similarly, there are a few set of questions here which asks to try and understand the students' interest, characteristics, and behavioral traits. Some details about some financial details to set some context about the financial situation of the student, and the need for scholarship requirements, the geographic preference of his career, etc. And now we move on to the psychometric assessment part. And all of these questions are dynamically generated by the AI engine. And here we can see the confidence score. And once this confidence score reaches a certain threshold of 60%, the assessment concludes. So as the student keeps asking and answering questions, new questions are dynamically generated, and all this assessment tries to do is perform a complete psychometric analysis of the student's mentality and provide a simple evaluation at the end. As we keep answering questions, we can see the confidence score moving up and down. This confidence score is maintained and increased, decreased, etc. by the AI engine behind the scenes. Now the assessment is complete. It has now mapped our personality profile to the two frameworks, VIASEC and Big 5. Once this is done, we can now proceed to look at the recommendations. So as per the analysis, it has now recommended that technology and engineering is the most relevant career pathway for our chosen interests and characteristics, and all other preferences we entered in the assessment, etc. so far. Now proceeding to the dashboard, a career network for the student is now loading. There are three main views provided to the student. Number one is the network view, then there's the journey view and the directory view. So the network view is especially of fundamental importance because it provides a need to graph view, a subgraph view of the colleges and all the related courses. For example, we have the courses associated with the colleges, and then we also have what are the job opportunities present here, etc. Next, we also have the directory view, which acts as a consolidated collection of all relevant data of all colleges, courses, jobs for the student which are relevant for the student's career. For example, we have the universities and then the related jobs, etc. Now there is also an AI chatbot included here in the application which can assist the student on any information he requires for any details, including colleges, scholarships, entrance exams. For instance, you can now move to the directory and choose to research on any college, for instance Maharishi Dayanand University. The AI now finds some information on the colleges along with resources, and it cites them in the response below. So this is the response from the AI about Maharishi Dayanand University. And finally, the third view we provide to the student is the Kanban and calendar view. So what this Kanban view helps the student do is it helps him track the progress for his or her career pathway. So there's a not started, in progress, and done status here. So all in all, what we try to provide in this platform is a unified one and all experience, where on one platform the student can also research about his career decisions, make informed career choices, and also track and manage his applications and manage his entire workflow and process for getting into a good career track.